Okay, so 2.5, we're going to talk about the last type of factoring. Out of the 4 that you'll be responsible for. But before we do that, I just want to talk about, a certain, it's not a different type of factoring. It's factoring that we've already done, but it's kind of a special case. Okay. So if I asked you to factor this, that means break it up into the multiplication of 2 expressions. So we learned how to do this type of factoring where we put 2 sets of parentheses and then we put in possibilities for the first 2 terms in each set, possibilities for the last 2 terms, and see if it worked out to 4x squared plus 4x plus 1. And it turns out that this is the factored form. Well, whenever you have a trinomial that factors to 2 identical binomials, these are the same, write it like this, okay? 2x plus 1 in parentheses all squared, okay? And whenever we get a trinomial that factors like this, where the 2 binomials we factor to are identical, we have a special name for that. We call it a perfect square trinomial. Which makes sense because remember, a perfect square, when we talked about perfect square numbers, a perfect square is any number that can be written as some other number times itself. So 25 is a perfect square because 5 times 5. 81 is a perfect square because 9 times 9. Okay. Well, algebraic expressions can also be perfect squares. So 4x squared plus 4x plus 1 is a perfect square because it can be written as 2x plus 1 times itself. Okay. We're going to talk more about these next year, but I want you to get used to writing it like this whenever you encounter one of these. So let's look at a couple of examples. And remember, and I strongly suggest you have this written down somewhere. The 4 types of factoring. Okay? Because you're going to reach the point where you're going to be given a question, asked to factor it, and before you even start it, you got to figure out what kind it is. What was the first one we did? GCF. What was the second one we did? Sarah?
Was it multiplying the 2 binomials? Is that the actual?
Yes, but there are a couple of different types of factoring like that. X squared trinomial. That's the one where we go X and X, and then we figure out 2 numbers that have a sum and product of the middle and last numbers in the original. How about the third type? AX squared trinomial. That means there's a number in front of the x squared. In number 2, there's no number in front. So it's still going to look like this, but it's not going to be x and x. It's going to be some other pair. There's still going to be numbers here, okay? And that's when I do that. Remember, we always check the middle term by doing the rainbow. So I just want to review that. I'll write down the fourth one after we do it today. But looking back at these, it might be helpful for you to write what kind it is, because then you can remember which method to use. What kind of factoring is this? What's x squared or ax squared?
X squared.
X squared. That's where, so I'm just going to go x squared try. Just to remind myself. And when I do these, two sets of parentheses, x and x, and then I got to figure out two numbers that have a sum of 6 and a product of 9. 3 and 3. So therefore, my answer is x plus 3 times x plus 3. Or, whenever they're identical, write it like that. Okay. How about the second one? What kind? Ax squared trinomial. That's why we have to do the rainbow thing. So, still looks like this, but I can't write x and x because these two have to multiply to get 25x. What two expressions multiply to get 25x squared? 25x squared. You're almost there. 25x squared. 5x, 5x. So I know that's going to work. Because remember, you can always check by multiplying back through. The two numbers have to multiply to positive 4, but notice there's a negative in the middle. That means that both numbers have to be negative, because remember, a negative times a negative is a positive. So what two negative numbers do I multiply by each other to get 4? -2 and -2. That is equal to positive 4. But then I got to check to make sure the middle works. And this is where I do my little rainbow. What's 5x times -2? -10x. And inside -2 times 5x. -10x again. And together those make, which is what I'm looking for. So we found it. Yeah. Okay. And then, of course, because they're identical, we write it as one of them squared. Okay? Again, that's not a new type of factoring. It's just a certain way we have to write our answer. The last type of factoring is what we call a difference of squares. And what does it look like? It's not a trinomial, it's two terms. Always a subtraction sign between them, because difference means subtract. And these are perfect squares, the two terms, which means you can write them as something else times itself. Okay? So how do you identify it? Okay? Two terms. Subtraction sign. Can't be addition sign. two perfect squares.
And how do you factor it? It's pretty straightforward.
It's two terms, okay? Or sorry, two sets of parentheses, two binomials. One's plus, the other's minus, always. These first two terms are the square root of the first term in the original. Last two terms are the square root of the last term in the original. Why does that work? Because if we multiply this back through and do our four multiplications, we get a squared minus ab plus ab minus b squared. Those cancel each other out. And you're left with a squared minus b squared.
Remember, multiplying is the opposite of factoring, or the reverse, I should say. Okay. So here's a couple of examples.
How do you recognize it's a difference of squares, two terms, subtraction sign? I can take the square root of these. So right away you write two sets of parentheses, plus and minus.
Automatic, all the time.
For these two terms, what times itself gives you x squared? X. What times itself gives you 25? We are done.
But, never mind.
So it's pretty straightforward once you recognize it as a difference of squares.
The second set, or the second example, again, two sets, plus minus,
And then fill it in.
what times itself gives you 16x squared? 4x and 4x. What times itself gives you 49y squared? 7y. And we are done.
That's it. Okay, so it's pretty straightforward. You don't have to do any guessing and checking. Okay, like find sum and product, things like that.
So that means the last one
It's a difference of squares. Okay. Those are the four types of factoring. And like I said, we're going to be doing these a lot. And we're going to be using them next year and in grade 12 quite a bit. So I want you guys to know these four types inside and out. Pretty much every test you get for the rest of the year will have factoring questions on them. That's how much I want you to know them. Okay? I want you to know them like your times tables. If you know your times tables.
Okay,